Okay, so this is part 2 of this video. The objective is going to be the same. Here we have x squared minus 5x plus 4 over x squared plus 2x is less than or equal to 0. First, we set the numerator equal to 0. So we need two numbers that multiply to 4 and add to negative 5. So that'll be negative 4 and negative 1. So we have a 0 at x equals 4 and x equals 1. And then we're going to set our denominator equal to 0. So we get x times x plus 2 equals 0. So x equals 0, or x is negative 2. These are the vertical asymptotes. So then we go ahead and we plot the points and we check points surrounding them. So we have negative 2, 0, 1, and 4. So let's check the values. Negative 3, negative 1, 1/2, 2, and 5. So at 5, the graph is going to be greater than 0. At 2, the graph will be less than 0. At 1/2, the graph will be greater than 0. At negative 1, the graph will be less than 0. And at negative 3, the graph will be greater than 0. So then we want when f of x is less than or equal to 0, that's going to be from only including the values negative 2 to 0, union 1 to 4. And we don't include negative 2, and we don't include 0. Okay, so we have x squared plus 5x minus 14 over x squared plus 3x minus 40 is greater than 0. So first we set x squared plus 5x minus 14 equal to 0. So we need two numbers that multiply to negative 14 and add to 5. So that's going to be 7 and negative 2. So this will be x minus 2 times x plus 7 equals 0. So x is 2, or x is negative 7. These are your zeros. Then we have x squared plus 3x minus 40 equals 0. We need two numbers that multiply to negative 40 and add to 3. That's going to be 8 and negative 5. So we'll have x plus 8 times x minus 5 equals 0. So x is negative 8 and x is 5 are going to be the vertical asymptotes. So now we can go ahead and draw these on a number line. So at 2 and 7, we are at 0. And then at negative 8 and 5, our values of x do not exist. So we're going to check points around these. And I always like to really draw like dramatic lines to really separate which values I'm testing. So at negative 9, we're going to have a positive value. At negative 7.5, we're going to have a negative value. At 0, we're going to have a positive value. And at 3, we're going to have a negative value. And then at 6, we're going to have a positive value. So we want to know when f of x is greater than 0. That's going to be from negative infinity to negative 8, not including 8, union from negative 7 to 2. But we're not including 2 because we have greater than, only than, and more specifically, not equal to. And then we're going to have union 5 to infinity, again, not including the 5 again. And we're not including the 5, though, because of the vertical asymptote. Here we have x minus 7 over 2x minus 2 is greater than 1. This problem is very challenging, so I'm going to write that. This is a very challenging problem. So let's just go through it one step at a time. We're first going to minus 1. So we have x minus 7 over 2x minus 2 minus 1 is greater than 0. 1 is the same as 2x minus 2 over 2x minus 2. So we'll rewrite this as x minus 7 over 2x minus 2 minus 2x minus 2 over 2x minus 2 is greater than 0, which will then be negative x minus 5 over 2x minus 2 is greater than 0. So now we can work with this as usual. First, we're going to set the negative x minus 5 equal to 0. So we'll get negative x is 5, so x is 5. That's a 0. Then we have 2x minus 2 equals 0. 2x is 2, so x is 1. This is a vertical asymptote. Then we're going to check our values around these. So we have 1 and 5. So I'm going to check the point 2. And I just realized something. I made a mistake. This is x is negative 5, not positive 5. So we don't need, we can still use that point, but we need negative 5. So we need to check a point between these. So we can use 0, and then we can use negative 6. So at negative 5, we're at 0. And at 1, we are, we have a value that is doesn't exist. So at 2, the graph's going to be negative. At 0, the graph's going to be positive. And at negative 6, the graph's going to be negative. So we want to know when x is greater than 0, and that's only going to be here. So that'll be from negative 5 to 1. That's when f of x is greater than 0. After the end of this lesson, you can solve rational inequalities.